Okay, let's do it. Okay. A hammock is suspended between two trees. Okay. To support the weight of a camper as shown, such that theta 2 is equal to 45 degrees. And theta, they're both say theta 2. Which one's which?
One is 45 and two is 60.
One is 45. Okay, good. Thank you. All right. Use the positive XY coordinate system shown in the figure. Okay. What I think that means is that they want us to use this as 0. Unless there's a figure that I don't see. No. Okay. Write all three vectors in rectangular form. Okay.
Wait, excuse me. Wouldn't the angle on the right be 60 instead of 45?
I'm sorry. I just looked up there and it said theta 2 and I didn't change it. Thank you. 60. Okay. Let's find vector T1. What can I say? And I want it in rectangular form. So if you like angles being here, you can use it here. You don't have to change it because the opposite, if we use sine, it's just the opposite over the hypotenuse, we would just, it would just change to cosine. But I know that's confusing. So if you want to use our regular angles that we're used to, then we can do that. Whatever you like. Which
That's
would do it like that?
Yeah.
Okay, perfect. So how do I find the rectangular coordinates for T1?
Well, you know W.
I don't care about W. W is not helping me right now. I mean, if you want, we can do W first.
Sides, right?
What?
Wouldn't it be the side,
No, 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 no.
the opposite? No?
Remember that these are vectors. They have no position. So the fact that it's written up there or written down here would mean nothing different.
Oh,
Do you understand that?
yeah.
So vectors act differently than sides of a triangle. So what I'm trying to say is, let me see if I can say this better. Let's call this T1x and T1y. Okay?
Mhm.
Well, T1x is equal to well, let me not do it that way. So if I want to find T1x, what trig function would I use?
I'm not sure because you don't know any of the
Cosine.
sides.
Doesn't matter. Cosine of
Cosine 45 equals
45
x over t1.
equals T1x over T1, right? So do I know T1? No, I'm trying to find T1, right?
Mm-hmm.
So I can say though that T1, I'm sorry, T1x, which is I'm trying to put in rectangular first, is equal to T1 times the cosine of 45 degrees. True?
Okay.
So I can write here T1, because this is T1x. This is T1x plus T1y. And those are the vectors T1x and T1y. So this is going to equal, well, T1x is equal to T1 times the cosine of 45 degrees. what's T1y gonna equal? And actually, don't forget, this is really important. This is negative because this is the reference angle. This is 0, 0. Okay, so that's going in the negative direction. T1y is going to be what?
The sine, 45.
Exactly. T1, positive T1 times the sine of 45 degrees. Yes?
Mhm.
Okay, here, let me erase this W for a second. So this is going to equal, well, the sine and the cosine are the same and the T1s are the same. So literally I can say the square root of 2 over 2 T1 times negative 1 or negative I plus J, can't I? Let me put this in I and J, sorry. Actually, I'm going to put them in red so you can see them. There's an I here and there's a J here. So this is going to be negative I plus J. Does that make sense? Because both of these are the square root of 2 over 2, and both of these are T1. So I just factored them out. Is that okay with you guys? Or do you want me to leave it separated? You tell me what you prefer.
I left it separated because I was working it in the rectangular form. I thought I had to keep it like
That's
that.
fine. No worries. And we will do that. I don't know what I'm going to need. So I just always like to simplify things if I can. So this would be this, right?
Yeah.
Same. Square root of 2 over 2. Square root of 2 over 2. T1 J. Hold on a second. I'm sorry, my alarm is coming off. So, Alexa, turn alarm off. Okay. T2 vector. Well, all of them are positive, right? So what am I going to do? And you could start getting used to, like if I have T2x and I'm using this angle here, it's going to be T2 times the cosine of 30 degrees. And T2y is going to equal T2 times the sine of 30 degrees. Do you understand that? You can go through all the pieces like we did here. Or you can see that they're all going to be the same. I mean, you can start with sine of 45, cosine of 45, and then sine of 30, cosine of 30, if you like. But this is what's going to happen in the end. Do you all see that?
Yeah.
Yes, for real? I mean, I don't mind going through all, I will take whatever time you need me to take. I know the longer it takes me, the more likely you're not going to stay till the end. So do you agree that this is true for the T2s?
Yeah.
Because it's exactly the same as the T1s. Excuse me?
Yeah.
That makes sense? All right. So this is going to be, the cosine is going to be vector T2. Cosine of 30 degrees, square root of 3 over 2. And this is in the I direction. Plus T2. Sine of, that's 1/2, right? And that's in the J direction. So I've done T1, T2. The only thing I have left is W, right?
But is
What
that where we
is
stop?
Excuse me?
Is that where we stop for
Where?
those? For that T2 vector,
This
that's
is
all we can
this
get?
is Well, so far, that's all we have. I'll show you in a minute, okay?
Oh, yeah.
This is vector T1, this is vector T2. Yeah, let me write T1. Okay?
Mhm.
Now we need W. What does W equal? Oh, this has a weight. The weight on this, I think I read 210. Does that say 210 pounds? 210 pounds? Is it
Yeah.
same? Okay, so it's right on here and it matches. Okay, so this is 210 pounds and it's just going straight down, isn't it?
Yeah.
So what would I
So
write
it's
there?
the Y or just the J.
So I just have the J, so I have negative 210 J. Agreed?
Yeah.
Okay, perfect. Now, let's read. So using the positive XY coordinate system, write all three vectors in rectangular form in terms of vectors I and J. Done. We actually just did A. Okay?
Mhm.
Now, it says if the weight of the camper is 210 pounds, determine the magnitude of the tensions T1 and T2 such that all of these equal 0. What that means is we want to put them into equilibrium. Did you watch the video I did with the skier on the ski? I think it was a skier on a chairlift.
Maybe not.
I really spend a lot of time and energy on those videos because I really want you to watch them. You kind of need to, okay? But I can explain what's happening here. Think about it like this. Let's say we're playing a game of tug of war, okay? There's a team on this side, right? And there's a team on this side. And there's a point in the middle that's going to stay right here, right? If these guys are stronger than, if the guys on the right are stronger than the guys on the left, then this is going to move this way, right?
Mhm.
If the guys on the left are stronger than the guys on the right, then it's going to move the other way. If they have the exact same strength, it's going to be, if I add these two forces together, if these are the same, this will not move. Do you agree?
Yeah.
Okay. That's why we did what we did up there. What we want to do is we want the camper, if he's sleeping between two trees, we don't want him to fall down. So we want to make sure that it's strong enough to hold him up, right? We also don't want him swaying from side to side or to go to one side because then he's lopsided. We want him to be centered and we want him to be still. That means all the forces together have to equal 0, which is what this says, and that's called equilibrium. When all of these forces equal 0, it's called we're in equilibrium. Does that make sense?
Yeah.
Okay. So I can only set the X values equal to each other and the Y values equal to each other because they're doing different things. Is that correct?
Mhm.
So what I'm going to do, I'm going to erase the guys. And I'm going to say, well, I know T1X has to equal T1Y. I'm sorry, T2X. Because those are the only X values I have. Isn't that true? Because W doesn't have anything in the X direction. So I can actually start with adding the X. Okay, let's do it a little differently. Maybe this will make more sense. I can say, let's add all the X values. Well, T1, I have negative the square root of 2 over 2 T1I plus square root of 3 over 2 T2I. Do you agree?
Equals 0.
Well, this equals T1x plus T2x. Doesn't it?
Oh, yeah.
Right?
Mhm.
And we want this to equal 0, don't we? Because we don't want him swaying back and forth. We want him stable. Is that clear?
Yeah.
Okay, so that means that since this is negative, it means that the square root of 2 over 2 T1 equals the square root of 3 over 2 T2. Okay? And let's simplify it a little bit. As much as we can, I can multiply both sides by 2, and I get the square root of 2 times vector T1 is equal to the square root of 3 times vector T2. Isn't that true?
Yeah.
Yeah? We're good?
Mhm.
Okay. Now we're going to do the same thing for, so this is one equation. We have another equation. The other equation is, so this is in the x direction. Now we're going to do it in the y direction. Again, we want all our forces to equal 0. Okay, so in the y direction I have, well, for T1 I have positive. I have positive the square root of 2 over 2 T1. This is all the j's plus 1/2 T2 minus 210 equals 0. Or I could say that all equals 210. Whatever you like. Okay? Now from here, it's really just algebra. So actually, I'm going to turn it back into the square root of 2 T1 minus the square root of 3 T2 equals 0. And, oh, sorry about that. I need to put another slide in here. Yes. I'm gonna copy this and then I'm gonna put it onto the next page.
Are you setting up a system so you can solve for T1
Yeah.
and T2?
Exactly what I'm gonna do. So let's do it. Let's start here. I have the square root of 2 T1 minus the square root of 3 T2 equals 0. And I'm going to multiply everything here by 2 as well. And I'm going to move the 210 to the other side. Okay, so this becomes the square root of 2 T1 plus T2 equals 420. Y'all agree?
Okay.
Okay. I'm gonna, I don't know what the best way to say it. So I'm gonna multiply everything here by -1, which is gonna give me, and I'm gonna move it down here. So I have minus the square root of 2 T1 plus the square root of 3t2 equals 420. I'm going to add these, they cancel. I get 1 plus the square root of 3t2 is equal to, 420. So T2, vector T2 is equal to 420 divided by 1 plus the square root of 3. And honestly, I wouldn't rationalize it if I were you. That would be a fine answer. If you want, I'll be happy to rationalize it for you. So now I know what T2 is. I can just plug it in. The easiest place to plug it in is going to be right here. So I have the square root of 2t1. I'm going to move that to the other side, equals the square root of 3t2 times 420 over 1 plus the square root of 3 t1 is equal to the square root of 3 over the square root of 2, 420, 1 plus the square root of 3. And I mean, I could definitely simplify these, but I'm just going to put that, I'm not going to make it any harder than this on you. And now I found vector T2. I found vector T1. And I already know W equals minus 210. That's the I think that asks for the magnitudes. Does it ask for the magnitudes?
Yeah.
So we have the magnitudes of each one of these. I'm aware that that is a long problem. If you don't,
Yeah, is there gonna be one like that on the test?
I
Or
don't
maybe
really, I
something.
honestly don't know, and I really can't tell you like exactly what's going to be on the test. I don't really want to look because he didn't tell me to like if he put it in that they're gonna have one of these and one of these, I would do it, but I've kind of got to be fair. So I can't tell you, but look, it's not that big a deal. Each one of these is, so A says write all the vectors in rectangular form. You know how to do that. You don't have to call it T1xi. You can call it xi, x1i. I don't care what you call it, but there's two triangles, right? You know how to find the x and y values of the two triangles just with cosine and sine, right?
Yeah.
Is that true? Yes? I mean, if no, tell me.
Usually when I know a side, it's the fact that
Excuse
we
me?
didn't know any sides.
Say it again.
In this problem, it was the fact that we didn't know any sides and we're leaving everything as variables.
Yes.
That was a little bit
Yes,
confusing.
we are. This is but that's just algebra. We're setting up a system of equations. Because
Yeah, I mean, it
we have,
makes sense once it gets to the end.
yeah, we have two unknowns. We already know W. If we didn't know W, we would need a third equation. So for every unknown, you need an equation. We have two unknowns, T1, T2. That means I need two equations if I don't know them. So I just set up the X values to be equal. See here, this is like the clue. If I add all the vectors, it has to equal 0. But actually T1, well, they're just asking for the magnitude, sorry. So what I'm trying to find, like if I were to add those and they would be in rectangular form. So the X values would have to equal 0 and the Y values would have to equal 0. Isn't that true? If we just started here.
Yeah.
So you have to separate them. That's how you get your two equations. You set the X values equal to 0. You set the Y values equal to 0. and then you solve. That's really all I did. All of A was just setting it up in rectangular. B, I just added the X values, and then I added the Y values separately and made sure that they were equal to 0.
Yeah, I
Okay,
just did it entirely wrong because what I did was I used 210 as the T1Y right from the start.
oh, I see.
I
Yeah,
thought I could use that as this edge of the triangle, and then I used that to be the same as T1X since it was 45 degrees, and then I went from there.
you can't do that.
Yeah.
Sorry, you can't. Yeah, I am sorry. I don't think it's possible to do that because we're adding vectors, remember, and they're not all going in the same direction. Remember, yeah, they have to be going. If you watch the video, I called it head to tail. If you didn't, they probably called it terminal to initial. Like you start it, you draw the first vector, and then wherever it ends, you put the next vector at the beginning of that. And then wherever that ends, you like, if I were to draw this in vectors, here, let me draw it for you. Let me put another slide in here so you can see it a little better. So we can just copy this picture. Huh? Looks like I can. Let's see what happens if I put it over here. Okay. So if I were just to draw these vectors, let's say I drew T1 first. Okay. Then I'm going to draw T2. So this is T1. This is T2. And then I would have to come straight down here with W. And my answer would be this vector. This is T1 plus T2 plus W.
Wouldn't you want it all to come right back to the origin to equal 0?
Well, I'm just telling it, but it doesn't have to if I don't set it up right.
Oh, okay. Yeah.
Right? If I'm just taking these vectors, I don't know what their values are in the X direction and the Y direction at the beginning, right? But all I'm doing is saying, if I start here with T1 and I go like, because the arrow's going that direction, right?
Mhm.
Then I have to put T2 on the head of T1. And it's going in that direction. And W is definitely going straight down. So yes, it should be 0, so I made T2 too long. But
But if you had a
just
solution
adding
that-
vectors in general, if I don't need to make them equal to 0, this is how I would add them. Yes, if I wanted to make it equal to 0, I would have to make this T1, T2, and then W would come right back to the beginning. But that's only in equilibrium. It doesn't have to be. It's just that this problem says it is. But any way they go, that's what the vectors would look like if I added them geometrically. Does that make sense to you?
Yeah.
Okay, so I have to find the parts that go in the X direction and make them equal. I have to find the parts that go in the Y direction and make them equal. And you can see, actually, from this drawing, that from here to here, the X's have to be the same for T1 and T2, or else when I drop W straight down, it's not going to hit the edge, right?
Mhm.
That makes sense, right?
Yeah.
Okay, good. So the X values for T1 and T2 have to be the same, and the Y values have to be the same. Like the so the Y value to here, this is where T1 ends, plus T2. So this is T1 plus T2. And that's got to equal W, just from even the picture. You see it? This is Y, sorry. Like the amount it's going up from here to here has got to be the same as W, or else you wouldn't get back to 0.
Mhm.
right?
Right.
So that's what is really happening, because we have arrows going in all different directions, and when we add, they have to attach to each other differently.
So on a test scenario,
Mhm.
could we leave our answer for A in terms of T1 as a variable?
You have
Or would
to.
we have to then,
You don't know
'cause
it yet.
but once you found T1, you could go back in
I
and
mean,
plug
you
it
can
in.
go back and put it in, but it doesn't say to.
So you could just leave it as the
Yeah, it's
variable.
fine. Listen, if you find the right answers for both, I know that you know that they go together,
Okay.
right?
Mhm.
There's no net, it's not necessary. Plus, you'd also have to multiply by the square root of two, like it
Yeah, it
wouldn't
would be a
make
mess.
sense, right? Like it's a nasty number, whatever it comes out to, it's not gonna be helpful to get actual value. If you had a calculator, yeah, sure, you could put it back in and get some decimal number. But those are things that are not important. The important part here is that you understand what you're doing. And if you do exactly what I did here and then exactly what I did here, I know you know what you're doing. And Jordan actually goes through and grades them all. So as long as he can read it, he'll look for, if there's a mistake, you get partial credit. You should be getting partial credit. And I also told him to go back and, like, because I know someone came to me and asked me, what did I get wrong here? And I looked and he didn't make any marks. And I was like, what are you doing, Jordan? You have to tell people where they're getting things wrong. So he should have gone back. He told me he went back and regraded things so that he showed you where you got things wrong. So that should all be handled. This class goes really fast. I'm well aware of what I'm asking of you. I'm asking more than I should. I'm gonna turn the video off. Is there any more questions that you would like to ask me that I should leave on the video? And then I'll just turn this off and I'll talk to you.